Building your own custom computer can seem pretty overwhelming at first, but stick with us as I go through building this slim custom desktop for everyday use, and I'll show you just how easy it actually can be. Alright guys, I'm going to try to keep this short and sweet, however, it may take a few extra minutes, so I'm just going to jump right into it. When building a custom computer, you want to take a look at what your required parts are. You can see I just did a quick little spreadsheet here. Motherboard, CPU, RAM, some kind of storage, whether it's a hard drive or SSD, video card, power supply, and absolutely a case or something to put it in. If you're not familiar with PC building, I recommend just buying a case that is suited for your components. That way it just makes things easier. There are optional parts, of course, that you can always purchase, but for this video, we're going to focus on the slim device, which does include a few optional things in it. But those are the required parts. You don't need anything else. With that said, I cannot stress enough, when you're picking out your parts, you want to read the documentation. It's extremely important, whether it is figuring out what video card the motherboard supports, whether or not it's the right socket set. If you're doing an AMD Ryzen, even though Ryzen does not support the integrated graphics controller, there are motherboards that support the older AM3 Plus and AM4 socket sets. So the motherboard says it has onboard graphics, but then when you plug in the Ryzen, you're like, I'm not getting video. So, read the documentation. It'll really help out. These are things that I just wanted to kind of go over real quick. Make sure that your motherboard socket type is what kind of CPU socket type it is. And as an example here, let's jump over to, Newegg here. I like their site just because of how they organize things. So you can see right here, I'm looking at motherboards. I've just gone over to components, motherboards. And right over here we can say socket type. And I can say, yep, I want AM4 because I'm doing a Ryzen build. You pick that and boom, all of these motherboards are now filtered down for Ryzen. We'll grab a random one here and just jump over, and you can see here that we've got, AMD A320, that is your chipset, which again, if you come down to the details here, you can see chipsets, AMD A320. If you're not sure what that is, Google it, look it up, see what that specifically says. But right here you can see CPU socket type is AM4. And then of course they, let you know it supports the Ryzen series processor. So you're like, okay, cool. So what would work? So we go back to components, we go to CPUs, desktop processors, and right here we can say, okay, well, here's an AMD Ryzen. Or if you're not sure about that and you just want to go down here to your socket set, you can expand this out and you can see right here, socket AM4. Of course, that's only going to give me Ryzen processors, but I know for a fact that I have chosen the correct socket type that matches my motherboard. So that's going to be really important. Other things you can take a look at, what kind of RAM does the motherboard support? If it says it does DDR4 dual channel, that's a maximum speed of 2.4 gigahertz or 2400 megahertz, then don't waste your money on faster RAM unless it supports overclocking. And if it does, the motherboard will say so, and you can pick RAM based on that. And that's really it. I'm not really going to go over much of the rest of this stuff. Some of these are recommendations, like your power supply needs 30% more power than required. If you go online and do some of these online power calculators, I think Corsair's got one, and some of the other people, what you do is you enter in the components that you're putting in it, and it'll give you some, calculation. It'll be like, oh, your system with this video card will take 400 watts. And you're like, sweet, so I only need to get a 400 watt. But think of it like trying to tow a trailer with a car. It can do it, but it's not good for it. You're going to stress out that power supply to the point that it's going to burn out really quickly, and you certainly don't want that. 30% more power is kind of a rule of thumb. Each power supply is slightly different, so that's why I say about. If you actually look at the efficiency curve, the more efficient a power supply becomes, it'll actually give you this sweet curve that will show you where it is. And you want to put your power usage right around that max efficiency. That means that the power supply is going to last longer. It also means you're going to be drawing closer to what you use out of the wall. And I'm not going to get into all the details with this because that's not the focus of the video. But look it up if you want more detail. Plenty of people have made videos. If you want me to make a video about it, I can certainly do that. Just let me know in the comments below and we'll jump into it. Case needs, again, the biggest thing right here, your form factor. If the case says that it supports an ATX motherboard, then if you take a look at some of these, you can see right here, this one says micro ATX. Micro ATX, here's micro ATX. So there's a lot of micro ATXs. Here is another micro ATX. Here we go. This guy right here is a ATX motherboard. Now, if you're not sure and you're looking at this long name going, I don't know what that is, just click on the motherboard, come into the view, come down to your specifications, and then down here towards the bottom, right there, it'll tell you what the form factor is. So it's very easy to get the information that you need. Aside from that, again, just make sure to read the documentation. I cannot stress that enough. A lot of people, myself included, I've been building computers for 20 years, but it's very easy to, buy a bunch of parts because you're like, I already know what I'm doing. And then you get it and you go, that doesn't fit. Whoops. So for the parts, we're going to start with the in-win desktop case. I needed a slim form factor case that had enough for an optical drive as well as a memory card reader. And I really liked this case just because it already came with a power supply and it was nice and compact. Motherboard is the ASUS Prime A320M. This is a Ryzen motherboard. And I've added 8 gigs of DDR4 3000 as well as a 1TB platter drive and 120 gig solid state for the operating system. Start by installing the motherboard backplate into the case in the correct orientation. The orientation is determined by the motherboard itself, so just take a look at the ports on the back and line it up. Next, you want to line up the motherboard inside of the case to identify which riser screws you're going to need, unless the case has the little bumps which replace the riser screws, in which case you just need to make sure it's lining up with the correct ones. Screw it down in place, hand tight, do not over tighten it, and you're good to go. Alright, for processor installation, make sure to lift the lever, carefully pick up your processor, and be aware of the gold triangle there in the corner. You just want to line that up with the marker on the motherboard itself, and let the processor gently drop into place. Do not push it. Once that's done, just push your lever back down and you'll get a little bit of resistance until it clicks and you're good to go. For RAM installation, just open up the small security tabs, line up the memory chips so that the gap in the chip lines up with a little tab inside, and firmly but gently push it in until it clicks. Easy as that. Heatsink and fan installation for the Ryzen is fairly straightforward, although you do have to remove the brackets from the motherboard prior to. Once you do that, you just take the included heatsink and fan and set it down on top of the processor gently, lining up the screws. Next, you want to tighten them down just enough so that all 4 are connected before you completely tighten all of them down. If you do it one at a time, that can actually cause warping and cause things to crack. Now, I did find out that this caused a problem with the orientation I had. The plastic around the fan was actually pressing down on the RAM there, so I had to reverse the orientation in order to get that clearance. Once that's done, you simply take the power cable for the fan and plug it into the motherboard's CPU header plug, which, of course, you can find in the documentation. For the rest of the components that get installed into the case, this case made it really simple. You can see everything was very keyless. The optical drive mounted right to this bracket, and you can see underneath is the place where I was able to plug in the SATA drive. Now just keep in mind, as you're doing this, it's really up to you if you want to run your power cables and your SATA cables at the same time that you're mounting things. For me, I got everything prepped, and then because of the size of the case, I plugged all the cables in and then fitted it into place and kind of tucked it into that little corner next to the power supply as I mounted things. And that made it a little bit easier going forward. The optical drive there, of course, just used those little green pins you pushed in instead of screwing it in. The only trouble I had was this memory card reader. It didn't actually fit without the cable coming out and going into the fan. So you can see I just cut an extra hole off to the side and rerouted the USB cable, and that worked beautifully. It just slid right in, and you can see there that I still had a gap without any cabling or anything pushing against that fan, so it still got good airflow into the case. The input-output pins are probably the hardest part for every build, simply because I've got man hands and these things are tiny. Some motherboards come with a little adapter, which make it a little bit easier, but really to figure out which goes where, just read the book that came with the motherboard, because every motherboard's slightly different. And it really doesn't matter which one is positive and negative since they're all instance buttons. Anyway, but here you go. This is the case with all of the cable run. I've only got the video card next. Starting with the mounting screw for the back bracket, you can see in the top corner there. In order for the video card to fit inside of this slim case, I actually had to swap out this bracket for a shorter one. So removing the 3 mounting pins that are associated with the bracket allowed me to fit it into this particular case. Now, in most circumstances, a standard mid-tower or full-tower case is going to be large enough that you won't have to do this. But just keep in mind, if you've never worked with a slim case before, this is going to be one of the steps that you'll have to take. And you can see I just used 2 more the same screws to just remount it back into place. Once it's all screwed back in, it's just a matter of moving cables out of the way and firmly but gently, as always, plugging the PCI graphics card into the slot. After that, you want to make sure that everything within the case is firmly seated and plugged in before going ahead and getting ready to boot up for the first time. Now, once you've booted up, the one thing you want to check for is make sure all of your fans and everything comes on. As long as you're getting power to the board and all of that stuff is spinning, it should post. And you can see here with this particular system, only took a few seconds before it actually posts. And I went ahead and hit delete and brought us into the BIOS to make sure that things are going to be functional. And I want to check to make sure everything's reading correctly. After verifying that everything was running correctly, just plug in your installation USB of Windows, and you will find that it will automatically boot to that. Follow the on-screen instructions, and within a few minutes you should be good to go. Now you'll notice in this case, it was telling me it was about 17 minutes of total time remaining. However, after 5 minutes, it was completely finished and installed, and then it was just a matter of installing drivers and things like that. After Windows is installed, reboot back into your BIOS and go into the XMP profile for your memory, simply switching it from the default to Profile 1, and that will boost it up to whatever speed is supported by the motherboard, if in fact you got overclocked memory. Well, I hope this video was informative for you. I hope you learned something about building a desktop or maybe building a slim desktop. Go ahead and hit like if you liked it. If you disliked it, hit dislike. If you have any suggestions, please leave them in the comments below. And as always, thanks. We'll see you next time.